In this video, we will discuss how to use some additional sum formulas. We started talking about these in earlier sections with arithmetic and geometric sequences. So when you first look at this particular sum formula, it should look pretty familiar. What we've got is an arithmetic sequence. We've got a sub n equals n going on here. So the first term is 1, the second term is 2, and on down the line. This should look a lot like the sum of an arithmetic sequence, because that's really what it is, because we've got an arithmetic sequence. So if we wanted to, over here, find the sum from 1 to 100 of just each term, this is saying 1 plus 2 plus 3, all the way up to 100. And in order to do that, we could simply follow this here formula. So n is 100 in this particular example down here. So you plug in n equals 100 and evaluate it pretty easily. And that is 5,050. So if you want to look at some of these alternate formulas, you could get another one here is the sum of n terms of the expression I squared. So this would be 1 squared, 2 squared, 3 squared, 4 squared, all the way up to whatever this number is squared. So we'll take a look at, in this particular case, 6. So what this is saying is 1 squared plus 2 squared, all the way up to 6 squared. And again, it's as simple as plugging in n equals 6 here. Here, 6, and evaluating to hopefully get 91. Pause the video for a second and work that out, just to make sure that you're A-okay there. This would be 6 times 7 times 13, all divided by 6. And let's look at one more before we're done. And that is just a list of the rest of the special sum formulas that go on for powers of integers. Okay, so we've got a third power here. All we do again is plug in whatever number is up here, you plug in there and there. Whatever number is here, plug in there, there, every time you see an n, and that's how we do it. So make sure to check out the practice problems that are in the 9.4 practice worksheet, and let me know how you do.